Problem number 15. F of x is this function defined as this integral here. So note the important thing to realize here, where is x in this expression here? We're integrating with respect to t, but when we integrate, we end up with an x in it because x appears in the bounds. And so there are 4 parts to this question. But really the first part, find f prime of x, this is really the important part of the question. Everything else just uses f prime of x. So I want to thoroughly go through how do you find f prime of x here. So we're taking the derivative with respect to x. I'm just recopying this here. Recopying this expression here. And so when you have this kind of thing for the fundamental theorem of calculus, what happens, oops, I forgot the -8 here. What happens is that everywhere is that your answer is just going to be the following. So the first thing that we want to do is that we want to start recopying the integrand here. 4 minus the cube root of something plus 8, where I've intentionally left that something blank here because the next thing that we need to do, let me put parentheses here, the next thing that we need to do is that we need to replace every instance of t here. There's only one instance of t. We need to replace every instance of t with x cubed minus 8. Okay, now there's one more thing that we want to do. If this was just x as the upper bound, we replace t with x and we'd be done. But that's not what we have here. We have a function of x that's not exactly equal to x. We now have to multiply by the derivative with respect to x of this right here. And so our answer ends up being for f prime of x, 4 minus the cube root of x cubed minus 8 plus 8, so that just becomes that, times the derivative of this is 3x squared. We have the cube root of x cubed, excuse me, so that's just going to be x. So it's 4 minus x times 3x squared. So once again, when you're being asked to find the derivative with respect to x of an expression that's an integral where x is where this is an upper bound, the upper bound here is a function of x, you replace t, the variable you're integrating with respect to here, you replace t with that function of x, and then you multiply by the derivative of the upper bound here. Okay, so this is part A. Now parts B, C, and D, this is all now just a calc, like that was a Calc 1 problem, but a Calc 1 problem from earlier in the course. So for the critical point, so when is this equal to 0? It's never going to be undefined. So 4 minus x times 3x squared needs to equal 0. And so the critical points are when x is equal to 4, when x is equal to 0. Intervals for increasing and decreasing. How do we do this? Okay. Between, let's say here, if x is bigger than 4, this is positive, this is negative. So it's decreasing over here. If x is between 0 and 4, this is positive, this is positive. And then if x is less than 0, this is positive. We're squaring it, it's still positive. So it's increasing everywhere. Less than x is equal to 4, it's decreasing, x is greater than 4. And then equation of the tangent line to the graph of y is equal to f of x at x is equal to -1. How do we do that? Well, we want f prime of -1, and we want f of -1. Okay, so f prime of -1, just plop in -1 here. 4 minus -1 times 3 times -1 squared. And so 4 plus 1, that's 5, times 3 is 15. F of -1, so we have to plug it into this original integral here. -1 cubed is -1. And do you see what's going to happen here? This is -9. So we have an integral from -9 to -9. This just ends up as 0. So slope of the tangent line, okay, let's just fill in everything here. Slope of the tangent line is 15, and the x-coordinate here is -1, and the y-coordinate here is 0. So here is an equation of a tangent line there. Okay, that's problem 15. Problem number 16 here. Okay, in order to do this, easiest way to do this is to multiply through, distribute out the multiplication of the numerator, divide everything by x to the 1/3, and then integrate each of the terms separately. So what happens when we do this? Okay, so the numerator becomes x to the 1/3 plus 4 minus x to the 1/3 times 2/3, that's minus x. Then minus 4x to the 2/3 divided by x to the 1/3 dx. Okay, so x to the 1/3 divided by x to the 1/3 is 1, plus 4x to the -1/3. Negative x divided by x to the 1/3 is negative x to the 2/3, and then minus 4x to the 1/3 here dx. Okay, antiderivative of each one of these terms here. Antiderivative 1 is x. Antiderivative x to the -1/3, add 1 to -1/3 to get x to the 2/3. And then we need to divide by 2/3, which is multiplying by 3/2. Then add 1 to x to 2/3 to get x to the 5/3. Divide by 5/3, that's multiplying by 3/5 here. Minus 4 here, let's see, we need to add 1 to 1/3 to get x to the 4/3. Divide by 4/3, multiply by 3/4 here, and then plug in 8 and 27. So we end up with, okay, when we plug in 27, okay, 27 plus, this will be 6 times 27 to the 2/3, minus 3/5 times 27 to the 5/3, minus 3 times 27 to the 4/3. All of that minus what we get when we plug in 8. 8 plus 6 times 8 to the 2/3, minus 3/5 times 8 to the 5/3, minus 3 times 8 to the 4/3. Of course, we can simplify this expression if we want to, because we know that 27 to the 1/3 is 3, and 8 to the 1/3 is 2. So we can do lots of those replacements if we desire.